Well, welcome everybody to our first evening panel. How have you enjoyed the first day of CppCon so far? Have you had a good time? We have. Glad to hear it. We already know you're dedicated / there is something wrong with all of us for a panel that starts at 8:30. So we admire your resilience, and I think it's going to be a very interesting panel. This is not the biggest panel we've ever had. This is actually the same size as the very first Grill the Committee panel. It was then called Grill the Committee at the very first CppCon back in 2014. And it's great to have a range of panelists, all of whom are active on the Standards Committee. Some of them have been active for a long, long time. You might know Bjarne, the second from the left, in case you're wondering. And there's others like Andrei, Wave Andrei, at the other end of the panel, who has been doing C++ a long time, but has only recently been participating regularly in the Standards Committee for the last few meetings, the last couple of years. And we've had chairs, subgroup chairs, chairs emeritus, people who are very have never chaired a subgroup, but who regularly work on proposals and have a major impact. For instance, Barry, I don't think you've ever chaired a subgroup or assistant chaired.
SGX.
Oh, okay. My apologies, but still it doesn't take away that you've written a lot of great papers on reflection and language and evolution features. So we have an eclectic range. I'm going to leave this slide up, which tells you who everybody is. Here's the format we're going to use. In past years, we've had like 80% of the questions from the audience, because we want audience participation. We are still going to do that, but we're going to start about halfway through. And the reason is because some of the questions are the same each year, and then we get feedback saying, same questions as last year. So what we're going to do is I'm going to start with some questions to drill into what's in C++26 and other timely topics, except AI, because AI has its own panel tomorrow, so we're going to try to defer most things about AI to that. We might still mention it, but that's why that topic has its own panel tomorrow. And that'll give us a sense of who these folks are, and then we invite your questions. I'll give you the signal. The microphone will be right here for a cue for you. But just to get started, we have the summary of everybody. I'd like to just go through everybody. Maybe we can start with Barry and do each row. Maybe say a couple of words about who you are, but the question I'd like for each of you is, we are now at a point where C++26 is about to be ratified with major features like reflection, std execution, send to receiver. What would you each say is the single most transformative thing that the audience, the developers, should know about the standard? And maybe Barry, you can start us off.
Yeah, so hey, I'm Barry. I'm an engineer at Jump Trading. I think this is kind of a freebie because the overwhelming correct answer is reflection. It is an incredibly transformative feature. It's one I've spent a ton of time working the last few years on. And one of the things that I'm excited about is kind of like, we all like our bad programming tricks, but like it allows you to write things more straightforwardly, then like you don't have to do the tricks, but also like it opens the world to what's possible. So a lot of stuff that wasn't possible before becomes possible now. There's a lot of stuff that like I don't even think might be possible now that someone's going to figure out how to do. So I'm super excited to see what that future will end up looking like.
Thank you. Ruslan, please introduce yourself.
Yeah, my name is Revzin. I'm working for Intel,
I
and
like leader of the parallel algorithms library that we're doing, and also co-chair of SG1 concurrency and parallelism. From the groundbreaking feature, despite I'm co-chair of concurrency and parallelism, I believe it's reflection, honestly, because you guys basically build the language within the language, and it's like the whole new world that we need to learn and change the way we were thinking, what we can do and how we can do that. And I know it's already very powerful. It's going to be more powerful, hopefully, for C++29, so we can have like all code generation, even like without cout, as like what's your example that you brought up, but really with the facilities of the reflection itself. So it's just endless capabilities of doing something at compile time. That's great.
Thank you. And Gabriel Dos Reis, who's our chair emeritus of SG12 and many other things, designer of modules and other credits.
Yeah, so at Microsoft, these days I work on safety. and a few other things. C++26 looks to me like a Christmas tree. Everybody has something on it. I guess the thing that I'm looking for the most to is the library framework of std execution, the senders, the receivers. Haven't programmed a lot about it. I've asked my colleagues like Gore or friends like Ville who have done work with them. They all sing the wonders of the library libunifx, which being used in the fields, and they all tell me, oh, I can do these things without worrying about data race and other stuff. So I'm looking much forward to that so that I can spread the words within the company and in the community.
Thank you. Next we have Guy Davidson, and before you talk, let me just give you a breaking update. So today is Tuesday. 6 days ago, last Tuesday, our parent committee of the C++ committee, SG12, which is all programming languages, was selecting a successor for me as convener because I've done it. Some people say, well, why are you stepping down now? So because the question isn't that. It's like, why have you stayed around so long? It's been 22 years. And so I still am going to be very active in the committee, but I want to do more technical work and let somebody else lead. And so there was a decision that Guy is going to be the next convener or chair of the C++ committee starting in January, but we're already going to put him to work 6 weeks from now at the Kona meeting because I want a lighter load, so I'm going to make him do work. So thank you, incoming convener of WG21.
Well, thank you, Herb.
Oh, and before I forget, we had several qualified candidates, including John Spicer and including Jeff Garland. Jeff Garland also happily volunteered, and I think maybe, hopefully, will continue to take a role in addition to what you're doing with the library working group. So definitely want to acknowledge, it's always great when you have multiple qualified volunteers. That's a sign of a healthy group. So sorry to interrupt you there, Guy.
No, that's fine. I imagine I'll be getting a lot of that over the coming years.
I'm sorry. You signed up for this.
I know I signed up for this. My national body signed me up for it, in fact. Hello, everyone. My name's Guy Davidson. I work for a company called 6 Impossible Things Before Breakfast. I am a game developer, and my company, or the company I work for, is making a game engine. We're in stealth mode, which is why you've never heard of anything that we've done before, but do look out for it. There's so much in 26. So I'm going to take a slightly tangential response to the question, what would be most transformative? And I think that you should make it your New Year's resolution to read the front matter. The first few clauses of the C++ standard are enormously accessible and will explain a lot of things. You don't have to read the whole standard. No one's done that. Not even the editors. I'm pretty sure, surely.
Richard Smith.
Richard Smith? Tim's.
Probably Tim Song.
Back to back, the whole thing? Oh. I suppose these are the people I'm associated with, isn't it now? Right, okay. Barry, all right. Okay, I withdraw my prior comment, but I still say you should try reading just the first few clauses of the standard. It will teach you an enormous amount. You don't need to be some legalese professional. It's really worth reading. That's what you should do.
I agree.
And Daisy, you are our Rangers Chair Emerita and also have helped with other groups. You are now doing a lot of AI stuff. Tell us what you're looking forward to in C++26.
Yeah. Hi, I'm Daisy Hollman. I'm at Anthropic, and I work on Claude Code for the past 6 months. I was Rangers Chair before that, worked on a bunch of other things. But I mean, it's going to sound like a broken record here, but definitely reflection. Although if you go back and check the tapes, I believe I said that the last 3 years on this panel, maybe 4. So I was saying it before it was cool. So I'm just going to claim that. But I really do think reflection can be transformative to the language, and I think we're going to see a huge amount of use out of it. We're going to see a lot more dry C++. We're going to see a lot less verbose C++, and I think this is going to be very good for the community.
Thank you. And Khalil, please introduce yourself.
Testing 1, 2, 3. Oh, cool. Hello, everyone. I'm Khalil Stell. I do research on exceptions on embedded systems. I do firmware and system development and stuff like that. And I do also custom electronics and things within that realm. If I had to say The obvious answer, I think, for this question is obviously reflection, but there was one more thing that came to my mind, which is I talk to students, I talk to people who are like, I'm not part of the committee, I'm not part of any standardization, but I'm just a normal guy trying to do work in C++. And what I really want is to be able to play with coroutines. And I've been waiting for standard task and standard generator for a long time, and now I have that, so I'm really excited about that. So that's the thing that I think is second best.
And Khalil, who's this guy next to you?
Hi. All right, so hi everybody, I'm Andrei, and I've been sober for... All right, so you should know that due to my position related to the speakers, all I could hear up until now, it was like... So I don't know exactly. So what's the best feature of C++ that's gonna come?
Yes.
Reflection, I'm gonna bore everybody, reflection, of course.
All right, well, why don't we continue with Jeff?
Yeah, so I'm Jeff Garland. I'm a co-chair at Library Working Group. Also Beeman Project Lead, also Executive Director of the Boost Foundation, which will become the C++ Collective very soon. We are renaming.
The Collective?
The Collective, yes.
You know the joke you're gonna get.
I'm not sure I do.
Say it.
Resistance is futile.
Oh, really? You're right, I didn't know that joke, wink, wink. Okay.
Sorry, I'm naive.
That's okay.
Please continue. Yeah.
So, as many of you probably are aware, Boost has decided as a community to have a different funding mechanism. So the collective will continue to fund C++ Now, the conference, and many other things. And the Beeman Project has become our primary initiative for getting better libraries, getting access for all of you to the libraries before they come to the standard or while they come to the standard. So that's really the focus over there at this point. So I'm going to take a completely different track from the other people. Reflection and all these things are amazing. But subtly, behind the scenes, stuff you don't see, hundreds of bug fixes have been made in both the library and the language, which means that you face less corner cases when you port code from one compiler to another, for example. Also, and by the way, I'm going to just make a call out, because there was 1998 and there was 2003, and 2003 was, I don't know, Bjarne probably tell me, 25 bug fixes. It was a small release. Many people appreciated that release very much because it was just fixing bugs that were a real problem. But many people don't know the standards committee does this all the time. Mm-hmm. We are constantly on a weekly basis trying to solve bugs that will become corner cases and problems in your code. So there are also many, many small features that improve the consistency of the library. These things mean that you're going to call, I can get a string view out of a string stream. That kind of thing, right? Small, tiny features that mean your ergonomics are actually better for the average programmer that's just doing things and obviously right. So I'm going to call that out. There are dozens of them, and you can talk to me afterward if you want to know more.
Excellent. So we have a vote for bug fixes as a feature. Hey.
Always good.
Absolutely.
Always good.
Timur.
Hi, my name is Timur Dumler. I'm the co-chair of SG21, which is the contract study group. So I believe the most transformative feature will be reflection, but other people can talk about this. I want to talk about the second most transformative feature, in my opinion, which is contracts, which for the first time in the standard will let you tell the compiler when you consider your program to be correct. And you can also tell the compiler what your program should do when it's not correct. And that's going to help you find bugs in the program. And it turns out that is a very, very, very powerful link to do this portably, scalably, and in a way that's just very configurable. That is a very, very powerful technique to make your code better, safer, and more correct. And I think that is going to be a very transformative thing, because with reflection, not everybody might use it directly. People might use the libraries that we can build with it, which are going to be amazing. But not everybody might use reflection directly in their code. But I think assertions, contract assertions, is something everybody hopefully will write directly in their code. And that's going to change quite a lot of things, I think.
Thank you. Inbal, please. And by the way, I still haven't gotten over that I forgot you were the SG10 chair. I'm so sorry, Barry. I owe you a beer. Inbal, please.
Okay, so hi everyone. It's great to meet you all, to see you. I'm really excited to be here. I haven't been here in the past year and the year before, so I'm really happy to come back. So I'm Inbal Library Evolution Chair. That's the group that is in charge of standard library features. And as you know, and you've been mentioned, Jeff is also, we collaborate on having the wording for those features go into the standard. So I really appreciate our collaborative work. And I don't know if you are aware of the hard work that's been done to deliver a lot of major features for C++26, including reflection, but others as well. So first of all, I wanted to thank for this collaboration. I would also want to say, along the lines of, with reflection that we mentioned here already, came a lot of const expr programming that was not there before. So for example, we now have const expr exceptions, and that might sound a bit revolutionary at first, but if you think about it, that's actually a very good mechanism for us to have better error messages from the compiler. So the idea of those is that they're not linking to runtime. That's actually Hanna de Sokova's proposal that she,
Let's give a round for Hanna. She's done so much work,
And she's been doing a lot of const expr things, including const expr in a lot of parts of the standard library. And almost all, yes, it's amazing. And I really just wanted to like also salute to this effort, because I think people do not understand the power of like const expr and compile time programming is one of the strengths of C++, and this is something that we've highly put a lot of effort on during this version, including contracts is an example of what you can actually achieve, but reflection and const expr programming is amazing. Just want to also highlight one more thing that was not mentioned before, SIMD, which is also an amazing, and Ruslan here was a contributor for that, and also Matush. So you can also talk about this. Matthias. But SIMD is also amazing because you now get to write relatively regular code, but you get better performance. So yeah, I think that's fun.
Thank you.
I haven't even mentioned std execution, but I trust other people to do that for me.
Nina.
So I'm Nina Ranz. I'm the committee secretary. I'm also the chair of the subgroup that does the communication liaison between the C and the C++ committee. I'm also implementing contracts in GCC. So I think you know where my answer is going to go. Reflection is almost certainly a game changer. Like Barry's right. There's no denying that's the biggest game changer. But I'm also very excited about contracts. We have been working on contracts for a long time. I think it's probably a decade since we started the conversation on contracts. And this is the first time that we actually have something in the standard. The story is not finished. We have a lot more work to do. We have a lot more discussions to have and solutions to find, but at least we have something in, and we can now start playing around with it, gathering experience and having more informed decisions in the future.
And let me just call out, since we're coming to you, Bjarne, thank you to Bjarne and Gabby, and to lots of other people who helped with const expr, including lately Hanna, but you two started this. You two started the const expr paper, and the fact that we can now take for granted that we can run most of C++ at compile time, this was not a given when I'll just editorialize for 1 minute, 15 years ago-ish, the question was, we clearly want to do more compile time programming in C++. Look, we're abusing templates to do it. We want it that badly. Oh my goodness. We need a language for this. What should the language, the compile time language for C++ be? It was not obvious that the answer was C++ itself. It could have been some scripting language, some one-off thing that did some things and was yet another thing to learn. It is remarkable that we have made C++ its own compile time language and are now shipping essentially a C++ interpreter inside every C++ compiler. So thank you. But back to the question, what is the most transformative thing you think people should know about 26?
I'd like to comment to people here who wasn't around when we got const expr in. that it was not easy to get in. It was not easy to get in. There was groups in the Standards Committee that loudly proclaimed it not only impossible to implement, but also useless. We've come a long way since that. I think I have to express a certain amount of concern about C++26. I am not very excited, and I am worrying about the committee. I see too little concern about coherency and different parts of the language working together. We are still not fully integrating coroutines, which without coroutines we wouldn't have been here because they were my bread and butter for 10 years. So I worry about how things work together. We are not designed by committee. We are designed by a federation of committees. We have as many committees and committee chairs as we had members when we started. And this worries me. A lot of people don't really understand the whole language or care about the whole language. That I worry about, and I think we should work on coherence and direction and focus on end users rather than the pleasure of expert committee members. Okay, so I'm going to comment about features. And I guess I voted with my feet this morning by showing the use of static reflection. But even there, I worry that static reflection is getting too complicated, too involved, and I worry whether it will open more possibilities for safety and security problems. It solves a lot of stuff I wanted. About a couple of years ago, I wrote a paper about 6 use cases I wanted covered. If I'd gotten those and then waited to see what was happening afterwards, I would probably have been happier today. Next, we get the executor model. I have not been able to follow up on it in all details lately because there's this overwhelming amount of stuff that is coming from the committee, and we have trouble getting the details right, trouble getting enough experience, trouble getting interaction between different features, and I'm next looking forward to seeing how the coroutines work in that framework. And then finally, I think that contracts should not be in C++26. It opens possibilities for ODR violations. It has many, many things that are implementation defined. It is not obvious how it works together with modules. It is not obvious that it had been tried out in a sufficient range of applications. It is incomplete. Coroutines, pointers to functions, class hierarchies, and the promises of it being fixed in the future. I am not sure I see the things being done right. I see the experience for the 3 languages I know that use contracts, Python, Eiffel, and Ada has not been learned or relied on, so I'm very worried about that. I think it is too soon. Not enough experience. Sorry.
Vittorio, last but not least. Oh, somehow we migrated. There we go.
Test. Hi, my name is Vittorio. Nowadays, I'm an independent trainer and consultant. Bjarne's words are very impactful. I have a lot of concerns, especially regarding reflection. I love what you can do with reflection, but even the idea of being able to drastically change the meaning of code just by changing the name of a variable is something that we have to get used to. And like having an annotation that might change the meaning of some code that's in some other place is something that excites me in a lot of ways, but also scares me. I also want to draw some attention to the things that make reflection a little bit more usable. And I'm talking about some nice utilities that we have, for example, with pack manipulation. We can now index a pack with square brackets like any other kind of sequence, which is really, really convenient. We can now destructure a pack into structure bindings, or we can do compile time loops with expansion statements. So all of these things are really appreciated. I love metaprogramming, and anything that makes it simpler, I think, is a win in my book.
So you've already started on some of the later follow-up questions I had. So let me just jump forward to contracts, since we already talked quite a lot about that. You've answered.
Can we get the monitors turned up? I can't hear anything back here. And I think
If there's anything we can do to make it easier to hear each other
that,
with the monitors, they may not be able to move them, but if we could do that, that'd
right. Just turn
the sound is
a
a little muddy.
bit. Yeah. Thank you so much. Sorry about that.
No worries. So with contracts, the question, one follow-up question is, contracts are in the standard. Not everybody's happy. For the audience, what is the one concrete thing that makes contracts worth shipping today? Or if you delay, what exactly is missing? So Bjarne answered the last part already. What about the first part? What makes contracts worth shipping today? I am unsurprised to see Timur's hand up.
I think there's a lot of stuff, but if I had to point out one feature, it's that unlike assert, like CAssert, which is the contract facility we have today, you can put pre and post on the declaration of a function, which means it is no longer in the body, it's on the declaration, it's in the header, which means the human can see it, the IDE can see it, it can display a nice bubble, these are the pre and post conditions of this function that you're using. The static analysis tool can see it much more easily, and it's going to give you much more meaningful errors if you do get something wrong. And the compiler can see it. And so that just makes it a lot more powerful and a lot more scalable than assertions the way we have them today.
Gabby, you had your hand up as well.
Oh, yeah.
And then Daisy after you.
Okay. So like I said earlier, C++26 looks like a Christmas tree. The part that worries me is I have no clue whether, as a whole, it's coherent. The early indication I'm getting is most likely not. And one of the sorts of incoherency, kind of a disappointment, is indeed contract. But I think most people here or in the community already knows that I've written extensively on the topic and why we should all be concerned and worried about the current state of contract. To be extremely clear and remove any ambiguity, I am very much in favor of the notion of contract. As a matter of fact, I've been working on it in the committee since at least 2014 or 15, and I have a lot of paper trails to prove that. So I'm not against the notion of contract. What worries me is the current specification. For I know, a lot of people have extensive experience with using, implementing a contract, implementing C++ in general, like someone like John Spicer, who is the chair of the study group that produced the contract spec, or someone like David van der Voort, a long-time contributor who contributed a lot to static reflection, and other people doing actual static analysis for a living have expressed grave concerns about contracts, the way it is currently specified. And even when we were in Hagenberg, the person who tried to demo, like get us to get excited about it, actually had to add extensions to Clang just to make it usable. And he explicitly stated, without these extensions, I'm unable to use it. And here's to showed how you could add contract to the standard library, for example. And if you remember, one of the concerns I had back in Tokyo was, hey, we should probably try this thing on the standard library to see how it works. And I worried that hasn't been fixed.
Daisy and then Bjarne.
So anyone who has been on the committee long enough knows that there are certain features that you have to just trust your committee members on. And contracts long ago was one that I decided I'm just going to trust my fellow committee members on. I'm not going to get involved. I'm not going to take a side. And that all changed about 6 months ago when I started to get into AI and coding assistance. And I think it is the single most important feature for that area. I know I'm not supposed to talk about that tonight. We're talking about that more tomorrow night. But I will say this, having spent the past 6 months really focused in on what does it look like to evolve programming languages for AI assistants and for agents. I think the consensus across the industry is that across all languages, contracts is the most important feature. It is a very compact expression of the intentions. It comes in the declaration and not in the definition. And so you can pull in a lot of information without pulling in implementation details. You can assume things that are going to be stable because they're at the declaration site and not at the definition site. These are all things that are very important for the way that agents at least currently work. We don't know how they're going to work a year from now. But like this is all very important. This is public knowledge, so I can say this. It is so important to us that we literally hired the person who was in charge of contracts for Rust. This is a very, very important thing for agentic environments, and we need to get something out there, and it doesn't have to work that well, because we can train on it. It doesn't have to work that well, but it needs to come out before 29.
Just to clarify, it sounds like you're describing just the fact that they're on the declarations so that the AI can see them is more important than the actual enforcement details and building.
The actual intentions that they express.
Okay.
And the constraints that they express that are not implementation dependent necessarily.
Bjarne, Nina, and then we're going to go on to a different topic because we do have other topics, but I'm glad we're talking about contracts because it is something that is an ongoing discussion point.
What Daisy said about what's good about contracts is completely true. I proposed it for C++20, and it was voted down for reasons I didn't appreciate. The problem I have is that we don't have enough experience with the current design. It is incomplete. As late as the shipment of the mailing last week, there was a paper saying that it is a security hazard. I worry that I don't understand a piece of code that has contracts in it, and how can I use the standard library if it has been implemented using contracts? I am very, very worried. It is premature, and I fear that a lot of the concerns I've had have been claimed to be solved, but by patch upon patch upon patch, as opposed to coherent design.
And Nina, please.
I'm going to take a slightly different look at all this. I think contracts and this discussion that we had here is a very good demonstration about how the committee works. When people say, why are things not in C++, it's because things are hard. I think we all agree that contracts need to be in the language. We do not all agree on what those contracts should look like. We do not all agree on what those defaults are. We do not all agree on when the contract should go into the language. But this is exactly how the committee works. We have people who disagree with things, who raise concerns, who keep us on our toes, and who keep bringing the conversation back so we do not make grave mistakes. It is true that we do not have enough experience with contracts. We had contracts in C++20, which was pulled out. We even had an implementation in GCC, which still exists. No one has been using it. Until it's in the standard, the compilers are not going to provide it. Until the compilers are provided, we're not going to get any experience. It is not complete. There is so much more work that we need to do. And I think, despite the fact that it's incomplete and it's not perfect, I do not, in my personal opinion, I appreciate we will disagree, we have not made anything that we cannot undo in the future and that we cannot fix and make better in the future. And that's the full, that's the point of that. That's the point of getting this out now, so we can gain experience and make it better.
So thank you for the breadth of perspectives. And I want to jump to a question, and I think there's some hands I haven't seen as much, maybe Barry and Khalil and Andre, for example. Maybe you can chime in. Feel free to raise your hands. I invite you. I'll take you first if you do. What requests are you all hearing from real-world users that aren't strongly committed in the Standards Committee's proposals currently? Your name does not start with Andre or Barry, so Barry, go ahead.
Yeah, so I guess I'll follow up. So just like in the committee, when I try to not pay attention to contracts or follow any of the discussions, I also did that here, so I'm living up to that. Not everyone can follow everything. So one of the things that I see people complain about a lot is like the ergonomics that we have, especially like our standard library ergonomics, right? And when people start to use Rust, for instance, like one of the things they notice is like how nice the standard library is by comparison. Like it's like it feels more batteries included as compared to ours, where like we have all these like nice generic programming facilities, but then like we didn't add starts with and ends with to string until like C++20 and contains until 23, I think, right? And we still don't have like dot split or dot join on string, like that kind of stuff. And so,
programmers use strings?
Yeah, apparently, I'm told. And so, one of the things, so one of the reasons I'm excited about reflection in particular is that while someone mentioned that like not everyone's going to like write reflection code, and that's certainly true. But I think what's likely going to end up eventually becoming true is that everyone's going to use libraries that were written in reflection. And so in the same way that you can see with Rust, what's the percentage of people in Rust that like write procedural macros? Like that's going to be a very small percentage. Like how many people use clap as their command line argument parser, right? How many people use serde to do serialization? It's like everybody, like that's just the thing you do. And so the ability to start actually writing more ergonomic libraries, like it used to be the thing on like Reddit where like every 2 months someone would post a new command line argument parser in C++. And it turns out that like you just cannot write a very good ergonomic command line argument parser, because like the thing that most people want to do most of the time is like, I have a struct with like 5 things, I want a command line argument parser out of it, just like do the thing for me. And that's like hard to do ergonomically right now. And it'll become extremely easy to do. And so I think at least on that front, we will at least start moving the needle a little bit.
Andre, Khalil, are there things that you all hear from people that you don't see represented well in the committee? People would love for us to do? Not to put you on the spot, but...
Oh no, it's more that like Barry did a really good job of explaining like the ergonomics issue. I guess if I was going to add one more thing, because I have a lot of people who are like, it feels somewhat painful. A lot of times I've actually had a lot of students being, oh, this is great, this is fun, I'm doing a great job, until they hit a really obscure error and they hit me up. And I was like, hey, cool, I spent like the last 3 hours trying to fix this error. And I was like, okay, let me take a look. And then I spend like a good 15 minutes trying to figure out how to fix this error. I'm like, oh, this over here was actually a copy. You didn't want that. You wanted to move here. And they're like, oh, I see. So in a way, actually, something that we encountered recently, I made this thing that's a span of a span. We can talk about that later. But for the most part, a lot of memory issues ensued. So I would say if there's any other thing, it would be safety. That's a big one, just ergonomics of safety and getting good results from like, oh, this is obviously, from a single TU, you can tell this is not valid code.
At NVIDIA, there's a large demand for code generation. In terms of source code generation, we have files that carry AI, literally, on their shoulders, and they are 30,000 lines long. And they consist of code that is repeated literally hundreds of times. Same code, there's one little tidbit, a little Unicode character that's different. And it's repeated across for a variety of types, sizes, size combinations, data, shapes, etc. making sure that that code is maintainable is an absolute chore for anyone. So if you're interested, just look at the Cutlass library. If you look at the sort by you know, do the trickaroo in the Unix command line, sort by number of lines decreasing, and your hair is gonna become really stiff in a second, even yours. So a facility to make that code tractable we're in dire need of that at NVIDIA. We're absolutely in dire need. Second, everything in AI is about tensors. It's about manipulating tensors. And we manipulate tensors by means of tuple. But before long, so tensors are multidimensional tuples with kind of an interesting deep structure. And it's the way tuples are working right now, they make it very difficult to manipulate when they model tensors. So some better support for packs, tuples, and that kind of stuff is also in. We're also in dire need of that kind of stuff. And I'll also mention too. So I don't want to destroy my time budget, but compilation speed. Everybody seems to like kind of essentially like we are right now. We're like relegated to. We're never gonna get compile speed. We're never gonna get modules that work. Our compilation times are out the window. Nobody cares about them. So I'm not sure what's gonna happen with that. I'm not very optimistic. Thank you.
Yeah. By the way, so we have Guy next and then Bjarne. You reminded me when you talk about generated code, which is very important, and we're going to do more with reflection, especially as we add things post-26. But it reminded me of debuggability, even now, of const expr code. Because so I happened to see, and I didn't read the whole article, but I saw an announcement today about JetBrains shipping a const expr debugger. So yay, more like that. I've been preaching that for a decade, that we are going to have demand for more and more of that. And we are going to have demand for debugging generated code because we have to see it to debug. We have to step into it. We have to see what, even as we're doing the generation, to make sure. So those are all kind of related to what you said. But let me go to Guy and then to Bjarne.
Probably harking back to what Barry and Khalil were saying, the thing that I'm hearing most of all is, can't you make it easier? Can't you make this easier? It's such a big language. There's so much to it. And we are making it easier. I think we are increasing the ergonomic value. But I heard a talk today about upgrading a code base from C++14 to C++20. And the error they had made, excuse me for this, but the error they had made was that they'd used a permissive command line on the Microsoft compiler, and so they'd written non-conformant code, and they'd put themselves in for a world of pain. I have a similar story in that I had to upgrade a game that was written in Visual Studio 2005, so it was on C++03. I had to upgrade that to C++17, but I had written conformant code all the way through because I'm particular like that. And it was a much easier job. And also, it doubled the frame rate of the game just by using a new compiler. And I think...
So I might not have heard you correctly. Could you say that again?
We doubled the frame rate just by using a newer compiler. And we could go back and slash and burn stuff and lose that backwards compatibility, but I think that's really important. It does, and I think it does make it harder to learn C++ because you have to say, well, we used to have this thing called hash include, and now, now we're on modules. I think teaching in general is still a problem. It'd be great to see proposals and how will we teach this proposal? How will we teach this feature? I think teaching materials, we can do better.
So Bjarne is still in the queue, and then I'd like to start. So if you want to start queuing for audience questions, let me insert a question before we get to you, because now 2 panelists have referred to modules. There was a post again on Reddit today, and there regularly are, how is modules going? And that relates directly to build speed, because that's one of the things that we're hoping for. People regularly ask, so what can we tell them about the progress of modules, the C++20 feature that people really want to use?
I do have something to say about this.
And I'm going to talk a little bit more in Wednesday morning open session at 8 o'clock. But the Beeman project is definitely interested in being modules first. We would like to get there. We have been working on this, and we have some experiences to share. There's a lot of details. I think that my sense, and I'm on tape saying this now, so I'm going to be, committed if it doesn't work out. I think in the next year, you're going to see the modules breakthrough, because I think it is now happening with GCC 15 actually getting it in.
Thank you. Gabby, you are Mr. Modules, so I'll give you priority if you want to answer, and then we have Inbal on that, but then I do want to get to Bjarne.
Okay, yeah, sure. So when we went with modules, we knew that this was changing dramatically how we organize source code. Dependencies became more explicit. And from there, many benefits will come out, and we have been seeing them. We have been dealing with an ecosystem that has grown over 40 years. So for some reason, MSVC happens to be the first to get modules in usable form out, followed by Clang. And this year in spring, GCC 15 came out with in a shape where, for example, you could say import stud. So the tooling ecosystem has been slowly improving to allow people to take more dependency. So I'm looking very much forward to the work that's going on in the Beeman project, because I think given the reach of your library, that will penetrate a little bit more, because now people take more and more dependencies, and we could see some of the benefits. I want to just take a few. So the first thing is have better code organization. I know we were not supposed to talk about AI tonight, but one of the things that...
It's not you can't mention it, it's just like, there is a whole panel for that, so yeah.
Okay, I'm not going... So one of the things that I did promise back then, and it's still, we're realizing, is that if you improve the code organization, you could improve tooling, right? So right now, everybody's like, it's a race, like who get there first. If you're training your model on C++ and your base model is include file, like include model, you're going to burn very, very quickly your token window, the number of tokens that you get, because things get paced. So now you get back to this kind of workaround where you're telling the system, oh, this thing just looked like that other stuff. Today you have models that will tell you when they see a block of code, say, oh yeah, that's the include stud vector. They will minimize that for you. But if you were using modules, the thing that is explicit in the source code is, let's say, import studs, for example. That is known with well-known semantics. And that's one of the reasons, for example, that if you look at the models for Python or C#, they perform a little better than C++, right? The other thing is the models, they are very good at doing fuzzy pattern matching. They're very lousy at doing arithmetic and logic. If you have a language that is interesting like C++, where just to call a function, you have to do like a lot of computations, or Rust, where you do a lot of computations too, then it becomes a little bit more of a challenge to the models. One of the most advanced ones that are around. I've been playing with them. Because they have to do computations and logic, right? Wait, I'm getting there. So to get those models to be more performant, what you want is you want to augment your sequence of characters with the semantic description. I heard something said earlier about contract. Oh yeah, we kind of summary in the declaration, but what you really want is you want the semantic description. You get that through, for example, when you implement modules, you have a semantic representation of your interface. That's another advantage of the tooling. So we have been ahead of the curve for, let's say, 10 years.
Maybe.
So As you were saying those things about AI, I saw the person to your right who knows a lot about AI.
I was seeing that.
I noticed that there is please, I think you should expect a rebuttal coming with someone who disagrees with what you said. We'll find out about that tomorrow, no doubt. Inbal, and then I want to get back to Bjarne on the previous question, which is what do you hear from users that's not represented in the Standards Committee papers well yet?
So that's really good that you brought it up. But I wanted to address modules, but I also wanted to address the previous question. So you heard quite a lot of concerns coming up here and open issues and things that we have to, and we want to think about. I also wanted to give you a bit more of like a wider scope of what's happening. So first of all, regarding modules, I actually, not referring to the implementation right now, but I do think we did had a discussion and effort to standardize, to go more toward tooling aspects through the standards committee. We actually considered an additional standard to address tooling. And I actually think that modules, in a way, if we use this right, and we also encourage our users, and we also encourage modern technologies such as package management, etc., we could actually tackle a lot of the problems that came up here, including compile times, including other things as well. Modules, we could deliver, or we could also standardize or look at standardizing the information about the module, including ABI version, for example. Those kind of things can actually solve a lot of the issues that came up throughout the committee for a very long time. So I think we're actually stepping towards a better future. And I just wanted to give you this aspect, because we did hear about a lot of problems, but I also think that there's a lot of solutions going on. Another thing that I wanted to address is Bjarne was concerned about coherence, and I also agree with that. And we are a large committee, and we are trying to also do this for our users. We want to give you more features. But for the coherence aspect, I've actually been working on this framework of policies that we are trying to do some kind of coherent agreement among the committee of what is important for us. And by the way, usability is one of those. So the last thing I wanted to say about, and actually address what Herb have mentioned about what user wants more. So I think actually good documentation, and we are working on this, and this is important for us. And I think maybe more in the recent years than previously. I haven't been in the committee for all the time that it existed, but I definitely am, at least personally, seeing a lot of value in that. And that includes talks like the one that you see on these conferences, and that includes CPP reference being updated with the latest the latest features when they're being delivered. And this is something that we emphasize and work on. It's not by itself. It is something that we actually put effort on. And also ergonomics, has been mentioned, is also context pair that I mentioned before is part of that. So I just wanted to give you this also kind of more wider perspective of the fact that we are working on those things, but yeah, on different aspects of them.
And now finally we'll get to Bjarne, but remember, we would like your questions. So the microphone is right over here. Please start queuing up if you have a question for our panel.
Just wanted to say that the reason modules are great is that they more directly expresses what it is we're trying to say. Include files is a hack. It was a hack that was put in because they couldn't do anything better back in 1974, and they knew it was a hack. We knew it was a hack. It's just hard to figure out. All the things people say here follows from the fact that we are now saying what we mean to say, rather than using workaround. Secondly, you mentioned the speed up when you got a new compiler. I have seen exactly the same in financial software. Getting a newer compiler means you use your hardware better. Okay, what I hear most is complaints about the complexity of C++. And whenever we add a new feature, people complain louder. because what is new is considered complicated, probably wrong, and probably slow, all of which tend to be wrong, but that's the way people see it, and they keep using the old stuff. They keep using sort of code the way they were writing it in C in 1978 or thereabouts, and that drags down the performance. It creates bug opportunities and such. We've been working on core guidelines. Guidelines are good. They're not good enough. You need enforced guidelines, and that's what we call profiles. We failed to get them into C++26. If they'd come in, I would say they were the most important because it allows us to save people from getting into the dark corners, to focus on better code. People think it is simply something to do with safety or security. The best way of getting good safety is to get better type safety. It is also the way to use the language better and simplify the code people write. We cannot simplify the language. We keep extending the language. We keep extending the library. What we can do is to provide simpler subsets of the language for people to use. And the profile philosophy is first you extend the language with more ideal facilities, and then you subset the result. And that's the way to address the problem I hear the most, both from users, expert users, novice users, and from students and from teachers. This is a very broad spectrum thing.
Thank you. So it looks like we have a brave volunteer. Please let us know your question.
Okay. Is this on? Yeah.
And feel free, more of you, to queue up.
I want to go back to earlier in the discussion, a number of you expressed some unease with the state of C++26. Bjarne, in particular, I think, mentioned a couple of features he felt were not well implemented and some other ones that weren't complete. I just want to point out earlier C++ standards have introduced features that were prone to misuse, like auto pointer is a great example of that. And there were other features that, in my opinion, like were not complete when they were released. Like parameter packs came along in C++11 and were annoying to work with until C++17 when we got fold expressions and so on. So I guess my question is, are the concerns that, for those of you who have concerns about C++26, are your concerns about it sort of on a higher level than stuff like that? And have you ever felt the same level of unease with earlier C++ standards?
And if I can just inject that open source was not always the case. For earlier standards, there was also features that have been implemented in closed source, because open source is not always been existing there. So that's also something that we need to keep in mind.
Ruslan, you had your hand up. Any others? Please raise. And I've got Bjarne, Gabby, any others over there?
Yeah, I think like for C++26, we have a lot of complex features being shipped like as a one standard. We have something similar in C++20, I guess, when we had like big four, like ranges, coroutines, concepts, and I forgot what was the fourth one? Modules, exactly, yeah. We were talking about that. How could I forget? Yeah. Yeah, and we still have like problems, like I think more problems with modules. We had some problems with ranges. Those were there. There was a library for like almost decade, I guess, but we still fixed those things. And I mean, did it successfully, in my opinion. A lot of people now use ranges. You know, there is no, like there are some improvements coming, but it's kind of iterative process. Despite like how much experience we have with this or that, there might be still some concerns or oversights because like we cannot think through everything. Again, C++26 is going to deliver like very complex features like state execution and reflection, and contracts maybe, because like people still raise concerns about those. I'm not that, scared about CMD, for example, or like parallel algorithms that we ship. Like they should be like more or less pretty straightforward. But still, yeah, there are some problems. I think we still can ship them so people start using them. When we have some concerns, we will think how to address them. And also, like, if we believe that something is incomplete, if we already identify some problems, we might limit the scope of this or that feature. We still have time frame for that, and deliver something later if we believe this is broken for now. But if we believe it's in a workable shape, let's deliver and let's see what the feedback will be.
Did I see a hand on the far side? I don't want to miss one if there was one.
I think it would be.
That's the near side, but I just want to make, yes, you're also in the queue. Okay, I didn't. So Gabby, I think, and then Bjarne.
I think I'll Bjarne first.
You can priority queue yourselves.
We know that we can't do a perfect large feature without feedback to see how it fits into the rest of the language and see how people use it. This was why when we started for the 3-year release cycle, we were thinking there would be a major feature coming in, and then the next release would make the use of it easier, fix any incompletenesses, fix any interactions with other parts of the language that we hadn't anticipated. On the other hand, I see the people think about like const expert and modules. There was a clear model, semantic model for what was going to go on, which we have more or less followed. And the only place where I saw we put something in and we were fundamentally wrong was something called external templates, which was an early attempt to do something like modules that didn't have a good coherent design. What I fail to see for contracts exactly is the overall plan, the overall coherent model, and it feels like a patchwork. And that I worry about.
Gabby, and then we have another question.
So, again,
oh, did I miss somebody? Oh, okay, Gabby Timur, and then we have another question.
So I think that's a great question. So to be clear, I'm not concerned because I think this is not perfect. That's absolutely not the case. Okay. First thing is, I don't think the rule for us is, oh, just put it in there, and if it doesn't work out, we can always take it out. It's not a good way of having an international standard. It may be a perfectly good way of doing some kind of continuous delivery to, writing a mail app, you just update if it doesn't work, you roll back. But an international standard for a programming language, I don't think that's a good model for it. Now, I'm going to give you concrete examples, right? So, Bjarne mentioned exported template earlier. That was right before I started doing, evolving C++ standardization. I studied in '97. We had garbage collection back in Conan. It was this agreement that I would say for political reasons, just to keep peace. Say, oh yeah, we'll put it in there. After a decade and a half, nobody really implements. Okay, take it out. When we put it in there, we made a promise to the community, and then we just like, hey, we're gonna take it out. Another example for C++20, when we had spaceship operator. I knew it wasn't exactly how I was designing it, but I also thought that whatever the problems were, we should be able to fix them. And as a matter of fact, my colleague Cameron De Camara, I worked with him tirelessly to come up with restrictions to the design that went into C++20, implement it, test it, and then talk to all the other implementers. So there is this big paper that we wrote to fix spaceship operator that had just about all the C++ compiler implementers. So that's an example where I thought it is not right, but we can write it. So, okay, we'll fix it. For contract, it is very different. It is, the way I say it, it's fundamentally broken. And I have been talking to other people. It's like, I may be very wrong. I'm not saying I have access to the truth. I may be very, very wrong. So I'm talking to other people who have experience implementing C++, other tools that will be needed, like the linkers. I've heard a lot of magic stories about linkers. We'll do this, linker will do that. And none of them look like, no, this is not workable. And Hagenberg, like, oh, to be able to use it for this thing, I needed these other extensions. Those are just like evidence that something is fundamentally broken. That is why I'm concerned, and I think it needs to be delayed.
Timur, can you keep it concise, and then we can get to the next question?
Right, I'm going to try and concisely make 2 comments on the things that have been said. The first is that there were claims that there's no consistent or coherent model behind contracts. I beg to disagree. Lisa Lippincott gave a talk last year here at this conference called Perspectives on Contracts, which talks you through the overarching mental model that is behind the contract design. I believe it's very coherent and very beautiful, so I encourage you to check out that talk. And the other thing is, the criticism about this is not working or that is missing. So we have deliberately designed this in a way that we can address all of the concerns that I'm aware of currently as pure additions to what we're proposing for C++26. So we won't have to take anything out, to change anything, but we can address those things like doesn't work in virtual functions, or there's no way to say this assertion must have this semantic across different TUs. All of these things can be addressed with pure additions to what we have in 26, which we can ship in 29.
Thank you. Next question, please. Whoever's next, yes.
So I want to address the contract as an end user. To me, this is the most useful feature of C++26. Can't wait to use it. So we could all agree, I think, that when lambdas came, they replaced bind, right? Bind was not so friendly. Or if const expressions replaced, for the most part, enable ifs, right? Or sphenes. So to me, contracts are at that level. And so in support of Timur, who I met for the first time today, so I have no relationship. And Bjarne, you care about end user. I am the end user. There are other features that I'm terrified of in 26. One of them is std execution. I use it. I use std from NVIDIA, but I don't know. The only good side effect of it, if it gives you coroutine machinery, it's really easy to spawn coroutines. Okay, that's a good thing. Otherwise, it's completely incomprehensible. I mean, to me. As far as reflection, my end user opinion is that I don't know, but it looks like it could be, we could be opening the Pandora box. My question for the committee is the following. Why C++ language is so easy to use incorrectly, it's so hard to use correctly? And why there is such a lack of good defaults, right? Like things that are easy to use. And there are other system programming languages, right, which are breathing at the neck of C++. One of them is Rust. One of them is Zig. So I have a question for the committee. How many of you actually played with Zig for at least 2 hours? Okay, good. So,
but that was your second question, so let's make sure we get the first one
so
too.
This is the point, right? Well, the point I'm trying to make is that you have one guy, right? And he has a sort of reflection, which is very easy to use. The compilation, right? Like your runtime code and compile code is just like exactly the same. Lex Friedman had an interview with Dave Palmer recently, right? And I think it was spoken in front of hundreds of thousands of listeners that Zig is faster than C++, and there was some numbers thrown around, right? So, and it's really much easier to use in my opinion, right? C++ grows in complexity exponentially. It's becoming more and more incomprehensible.
So the question is, what about usability? And we had at least one hand already. So Jeff, why don't you get us started at answering, and then we have Daisy and Barry.
Your problem.
Constructs actually.
But we'll let them get a shot, and they'll do their best to answer your question.
This is going to be fast. Your problem goes back to C and all the bad conversions that Bjarne demonstrated this morning and other things that are related to C compatibility. That is a huge problem in C++ that makes all kinds of nonsense compile that shouldn't. And it's not really with the newer features, it's with the old ones.
Daisy, Barry, oh, we have more hands. Vittorio, Bjarne.
Yeah, I mean, I don't have much to say either. I've been off working with a lot of Rust standards people for the past 6 months, and they don't have everything figured out either. Like, this is, you're seeing it a lot more because we're more public facing in terms of like our papers and everything. We are not a software project, we are a standards project, so that's a little bit different. There's a lot of other things going on, but like, this stuff's hard.
Barry.
Yeah, so I will continue to not comment on contracts, but so I think Zig is super cool as a language. For those of you that came to my talk today, I was inspired by a Zig talk actually, and so one of the things that I think Zig does very well, and one of the things that we do very poorly, as Jeff mentioned, because we inherited it from C, is our general like syntax scheme, right? Like, what are the things that you declare in a programming language? You have types, functions, and variables, and obviously in C++, two of those are ambiguous with each other. So that's kind of a problem, right? Like, you start, when we were like working on like reflection stuff, you start getting into like, well, what does int paren mean? Oh yeah, well of course it's a function that takes no arguments and returns int. Oh, did you think it was 0? No, that's not how it works, right? So, and this kind of stuff. So like one, that's like obviously very hard to learn. These kinds of issues are very hard to debug when you like get into like all this kind of syntax soup issues. But I don't think it's unchangeable, right? Like I don't think we're stuck with this forever. And so one of the things that Zig does very well, it's just like it has very uniform declarations for everything, right? It's a little bit jarring to read at first because pointer to T is spelled star T and not T star, but like you get over it and then it's consistent for everything, right? And it's really nice. And that is something that like we could potentially do, right? One of the things that like Sean Baxter showed us in Circle is like, well, you could come up with a schema where we just like hash pragma syntax that doesn't suck at the top of your file. And we just come up with like it doesn't have to be like a radical redesign. It just like, move around a couple things, make, variables and functions not ambiguous with each other, put the array bounds on the correct side of the name, like stuff like this, right? Like these are all like very little things, but like I think they pay a lot of dividends.
So I hear declaration syntax, OMG. So yes, I understand that. Vittorio, Bjarne, Inbal. I think I haven't missed anyone.
Yeah, so I want to echo Barry's sentiment that this is not something that cannot be changed. I've been trying to do this with my epochs proposal quite a few years ago, and I feel like there is quite a bit of similarity and overlap in the intentions and in the methodology, also with profiles and also what you're doing here with your CPP front. The idea is, we know that we have this historical baggage, this legacy, but we do have the opportunities to constrain some parts of the language, given some new notation or some sort of switch on a per module basis to change the defaults or forbid constructs that may be, dangerous, like implicit conversions. And I'd really like to see, more focus on this in the committee and trying to see how we can effectively change something in C++, creating a dialect, because that's what we're gonna end up doing without changing, how the language feels, how people approach it, but still making it a bit safer, a bit easier to use, and reducing the surface area. Because adding more things on top to simplify what's already there, it is technically adding something which is simpler, but it is increasing the surface area. And the main complaint I see from people is that it keeps getting bigger and bigger, and now you're going to have to learn more and more things. So we need to find a way to reduce the surface area in some way or form.
Bjarne and Inbal, please.
So you have in things you don't like, and you add another one to solve the problem, and now we have in plus one ways people are doing things.
There's an XKCD about that.
Yes, I know that.
standards.
This is why I'm trying to address it through profiles, where you can decide what kind of facility you want. And that is a subset of a superset.
Question, and I'm channeling Barry here. I think Barry might be thinking the question, can I have a profile that is called syntax that doesn't suck?
I very strongly am against that.
I just wanted to be very clear about that.
I want the token sequences. I want the language to be the same, the semantics to be the same. If you enforce a profile, you know you're using a proper subset of a superset of the language. If you don't check it, you get exactly the same meaning. It is standard C++. I'm not suggesting we change the syntax. I'm not suggesting we change the semantics. I'm very strongly against the same code in different places having different meaning, like contracts have. I think profiles is the answer to the complexity. It is the enforced version of guidelines. And guidelines do simplify dramatically, and it dramatically simplifies teaching also, which is important.
Inbal, and then please we have another slot for another questioner.
So I'll just be quick. So just a few things that you said. First of all, you said C++. C++ is a language being developed for over 40 years. When you compare this to newer languages, I would argue that you should compare newest standards to newer versions, newer languages. Because I really think that, yeah, as Jeff here said and others, that we have history, and that history makes sense, and it actually what brought us to today. But you also need to take this under consideration when you ask those questions, because comparing a language that exists 10 years, for example, to something that have been exist 40 years, and ignoring the development process of it is really, yeah. Second thing I wanted to say, I also, and it's kind of a continuation of that, I also agree with what Bjarne have said. I also support the idea of profiles, and the reason is that I gave a few years ago a talk that talked about abstraction layers. And in C++, you can do a lot of things, and you can dive deeper into your code if you need to, but you don't always need to. And when people are falsely doing this, or for example, you could use containers from the standard library, and that would be great, and you can have a very clear and understandable code. And if you're going to start using pointers for some reason because you've decided you need to, then obviously you're going to have things that are complicated, that are conflict. So I think that when you talk about this language, you need to talk about different abstraction layers and judge them accordingly, because if you need to manipulate memory using pointers, you're doing a completely different thing than if you need to create data and iterate over it and print it. So, and the third thing I just wanted to say, during my preparation for my talk on reflection, I looked at Rust reflection, for example. And again, I think Rust is a great language. I think all the languages actually have a space and are good for certain things. But specifically for reflection, Rust, what I've found and what I've seen is they have a library to manipulate AST and the abstract syntax tree, basically directly. Reflection we have is, in my opinion, is better, is a better syntax, is more understandable, is more user-facing, in the logic is more. So I would just ask that whenever those kind of claims come up, you know, please look at the facts, please observe facts and try to compare those things and have that, you know, information and facts when you consider those things, and not just go by reputation or that's it. Thanks.
We're going to go to our next question, but I saw Khalil react to what you just said about comparing the
Can I just say?
Oh, okay. Never mind.
Can I just say one quick thing? And that opinion about Rust reflection is not mine. There's actually, I found a blog post written from a Rust person saying we should look at C++ reflection. They've been doing a really good job. So that's not my opinion. That's, sorry.
One super quick one, and then we'll take a question.
Rust,
And then I have a wrap-up question.
I'd argue that Rust doesn't have reflection because in Rust, you have to mark the type that you want to generate code for immediately, but you cannot do that on a third-party type. It's not real reflection. You're saying, I'm defining a struct, and as part of the definition, I'm also going to generate, for example, the debug printing. But you cannot do it on another type. Reflection is much more powerful than that.
No, I'm talking about the sync library that actually manipulates AST, which is...
Yeah, but you have to do that in advance. It's not real reflection.
Please.
Can I say something about contracts and ODR violation from standard library implementer point of view?
And is it a question, please? So go ahead.
Well, I'm trying to debate against Bjarne.
You're very brave.
Yeah.
I'm kidding.
I'm an implementer of libc++ Clan's standard library. We've been shipping a hardened standard library for years. Basically, it's a hand-rolled version of contract with ugly macros everywhere. And we haven't seen any bug reports about ODR violation. Of course, we have our own solution for ODR violation by ABI tagging every single symbols in our standard library. And we use the compiler flags to make sure the different contract mode will generate different symbols.
Excellent. And do you have a question? We've talked enough about contracts. Do you have a question?
My question is, why do you think that we don't have any deployment experience of standard library?
I will answer that. Otherwise, you will get 13 answers. It has not been deployed widely at scale because it's not in production compilers yet. And that's where we're going to stop on contracts.
I totally disagree.
Yeah.
He's actually right. I deploy those flags in production because
I'm talking specifically about the C++26 design.
Sure, but it's very analogous.
I don't know who's first. Let's go with Nina because I'm going to go priority queue with who has talked the least.
I'm going to try not to trigger more controversy. I just want to do a little bit of advertisement. We now have implementation in GCC. We have in Clang too. Eric is somewhere around here. It hasn't been upstreamed yet. We are working on upstreaming it, but it's definitely available on a branch. It's available on a compiler explorer. We do have not just C++26, we also have additional compilation flags for certain possible extensions in the future. So please go around, play with it, get some experience, give us some feedback. If you need details on GCC and Clang, Eric is here, but you can just contact me and I will put you in contact with Eric and play with it, please.
So far be it from me to try to shut down discussion, which is impossible with this group. But let me ask this. Please respond concisely to say something that has not been said already.
Yeah, okay. Gabby here as an implementer, I work a lot on GCC. GCC has been shipping the assertions for a long time. Clang has been doing that. MSVC also has been doing it. And the hardened version of the standard library, C++26, has now been implemented by all the three major compilers, including MSVC. And all three of them have it under a very specific set of macros. And you might think this is scribbling, but it is not. This is the fundamental part of it. When you have macros, they expand to a certain set of text that is subject to ODR interpretation. The contract version is the one that is posing problem. So whatever experience deployment we have with all these three major compilers does not apply here. If you want to know more, because Herb is looking at me, he wants a concise answer, I'm going to say there are at least 3 papers in the mailing that goes in detail about these things, including one that's from Davis Chisnell, who already published not before, but one that is now in the standard in the mailing.
But that example is not new. We've been discussing like half a year ago.
Yeah.
That OB.
Something new and short.
Yeah, new and short. What you brought up have been. We were aware of this. That was part of the discussion on standard library hardening, which we voted for, and that was actually one of the things we brought up. So yeah, I just want to make sure that, there are different voices which make sense, but we were actually taking this under consideration. So.
Yes. But for everybody's, you're getting a glimpse into the give and take, as we've noticed before, in the committee. So there are concerns where, for example, something will come up, and some people will respond, we've been talking about that for 2 years or 6 months, or we've had papers on that before. And that may or may not be true. Sometimes it is, sometimes it's not. Even when it is, it shows there are sustained concerns. Well, your answers have not satisfied us. Let us try to say it again with more examples. And this is part of the robust conversation we regularly have. So welcome to the committee. And you can be part of these robust conversations if you join us at our meetings. I am now going to notice that we are nearly at time, but I would like to end with a forward-looking question. And I won't make it a lightning round because I'd say like 10 words or less, but I am curious as to what you all think. C++26 is nearly done. What do you each see as the biggest priorities that you would like to see, that you think are most important for C++29 and beyond? We can go in order, or shall we try in order?
Sure, we'll go
You're already there.
Not contracts. I would say code generation. C++26 only has one very narrow code generation facility, which is just define aggregate. And so expanding that to like full proper code generation would be incredible.
And to be clear, you're not talking about binary code generation by an optimizer.
No. Like
you're talking about generating
code as if you would write it yourself, kind of thing.
Ruslan?
I personally have more ideas about like parallelism. I think we have a lot to do. I mean, CMD is here, but we have a lot of improvements how we can make it work together with like the rest of the C++ standard library for for example, like random number generators or like some parallel algorithms, for example. Also, we can further improving our parallelism that we have already by adding ranges, numeric algorithms that we don't have yet since C++20, and also like including parallel version of those. And also, I think that we need to focus on the safety of the API, and I want to acknowledge that we already did, like we're moving to this direction, like doing some good job, I think, in improving the usability. Like again, CMD and in-place vector have some checked versions, unchecked versions. The same for parallel algorithms. We, with the new set that I'm going to talk more in details during my talk on Wednesday, come and see it.
Minus 50
yeah,
words.
it's just advertisement of my talk. So basically, we also added some bounds for the output, so do not have like memory overrun and all of this stuff. So yeah, we should focus on improving what we have and in building everything, like basically making
10 more
everything
words,
work.
Ruslan. 10 more words. Okay, great.
Yeah. Top priorities, Gabby.
Okay.
For post C++26.
So for me, first and foremost is improve the safety and the usage of the language so that by default, when you have newcomers, they are more incited to write by default the correct thing than having to step on landmines. So the first thing. Second thing is more coherence to the language. Like Bjarne said earlier, now we have a federation of committees, and the spec that we ship shows like we're shipping the org charts of the committee. We need something more integrated. Third is I would like the committee to take time to fix many of the bugs that we have, and not just pile new features over features, but fix the bugs like we did 03. That was bug fix to 98. That would be a great thing. Next is no. You say priorities.
So from now on, there is a limit of 3 per customer, and we've had 3. I'm going to move along to Guy because we're running out of time.
Let me finish, and then I'll...
Okay, you get a 4th. It's a baker's dozen.
Okay. Next is we need to find ways to bring the rest of the community with us, like upgrades, like put more emphasis on tooling so that you can... How easy it is to move from 17 to 20, 23, and 26, and 29.
I have a microphone, thank you. The AV crew have homes to go to, and I would prefer to remain impartial.
Awesome. Daisy.
I mean, I think if I get one, it's keyword arguments or named arguments. I have been a proponent of that for years and years and years. I think there is a very solid justification for that with the way that agentic coding assistants process information, and I think that it's the time to finally pull the trigger and do something very specific, syntactic about that. I know we're getting the ability to, in theory, do it as a library feature with like more iteration of reflection. I think we just need native syntax for it.
So I heard a reaction in the room as soon as you said named arguments. By applause, how many of you would love to see named arguments in C++? Which of you are going to write the paper? Just kidding.
Yeah.
But you're welcome.
It's harder than it sounds. We've been trying to do it for a very long time, but I think we finally need to just put aside our differences and do it.
Khalil?
Hello. All right, so actually, Daisy, I completely forgot about named arguments. I see them, I want them every single day, but I'm like, it'll never happen, and then I forget about them. There's, just to be a little bit weird, there's like this one thing that like I can't stop thinking about. I actually wrote or built up my own new exception format purely to handle the case of coroutines and how they handle exceptions. And I keep thinking that there might be some way to improve that. The issue that I'm talking about is that each coroutine has an implicit try-catch. So you must always, when you propagate through a coroutine, if you're going to let it go through each one of the sequences of your coroutines, you should drop back into the coroutine, go back into the catch, save the exception pointer, and then you traverse that wherever you need to go. I feel like there might be a way to keep everything within the unwinder. So things that I'm thinking about, things that I think that might be interesting into the future that people haven't considered.
Andrei.
Generative reflection. Everything else is a waste of time.
I'm going to go with safety and security, fixing the bad defaults and making C++ much safer than it is. It's never going to be perfect, but it can be much better.
So I also will say safety, but I will be a bit more specific. I think what we need to do is we need to stop plugging particular safety holes or like applying case-by-case improvements as we have done over the last many years. And instead we need to have a holistic strategy. Look at all of the UB and all of the other safety issues that we have everywhere in the language and figure out how to address it systematically. And we are now working on this. We have a paper, P3100, which has been, I think, very well received by Evolution. So I very much hope that we're going to have a complete and consistent story there for C++29. I think that's the single most important thing.
So to not repeat things that we said here, but there was this little thing that called internet. It's very, very common. So I actually think that networking would be great to have, and that's actually something that we're building upon standard receivers. That's another thing that we will work on, and I am very hopeful for. One of the long list of things.
I can't believe I'm going to say contracts again. But something that I'm excited about is a way of expressing contract semantics within the code. And one option for that is labels, which is one of the proposals we have coming up. So I'm kind of hoping we're either going to get labels or some other way of expressing semantics within the code, which I think is going to address some of the concerns that people have with contracts.
Profiles for safety and simplicity of code. And if we don't get them, everybody will do incomplete and incompatible approaches to the problems. And I do think we can get perfect type and resource safety without any apologies.
I want to see the language shrink. I want to see unsafe constructs become opt-in, not opt-out. Whether it's profiles or something else, that is the goal. And then please relax the restrictions on designated initializers. Let me put them out of order. I know what I'm doing. They're just aggregates of things without constructors. Let me put them in a different order, please.
So Vittorio would like to see the language shrink, and the first thing I thought was, after a whole long day of C++, I would like to see a language shrink. Different meaning of shrink. Oh, good, that actually worked. Thank you very much. You want to just thank all the panelists for sharing their expertise and participating today. So we hope you found that insightful, useful, a glimpse into the many-faceted thinking going on among experts that all bring their different specialties and strengths together. This is day one of a full conference, so be all rested up, don't stay up too late, pace yourselves, and be ready, bright-eyed and bushy-tailed for tomorrow's talks, including by some of the folks on this stage. We hope you enjoyed today. Thank you for coming tonight. Now go have a beer and then rest. Thank you for coming.
Thank you.
Thank you.